we're going to be solving y prime is equal to 2y plus 4y to the fifth. So we recognize that this is a Bernoulli equation because of this y to the n term. That is preventing this equation from being linear. So we want to modify this equation to make it into a linear equation. So from there, we can go ahead and use our linear equation techniques to solve for the implicit solution. So the first step is to divide both sides by the non-linear term y to the fifth power. That will give us y prime over y to the fifth is equal to 2y to the negative fourth plus 4. If we do that, we still don't have a linear equation, but we can go ahead and use a substitution to make it linear. We can look at this term right here, or we can look at this term right here and make a substitution, a linear substitution. We're going to call it v, and v is going to be equal to y to the negative fourth. Again, you could have it equal to 2y to the negative fourth, it will still work. From here, we can go ahead and find the derivative of our substitution. Using the power rule and chain rule, we're going to end up with negative 4y prime over y to the fifth. Remember that y is technically a function of t, so it's y of t. So when we take the derivative, we are using the chain rule. We have to add that extra y prime term due to the implicit differentiation. From here, it is very easy to go ahead and get the linear differential equation. We have this Bernoulli modified equation. We have two substitution equations. We can use all of that and create a new equation. We recognize that y prime over y to the fifth is equal to the left term of our equation. Therefore, we can make a substitution, negative 1/4 v prime. On the right side, we look at this and we see we have a substitution. So we can make another substitution, 2v plus 4. From here, we can go ahead and solve for v prime. V prime is equal to negative 8v minus 16. And then we can go ahead and use a general solution formula or an integrating factor to solve for v. I'm going to go ahead and use the general solution formula. If you have any questions on the integrating factor method, you can look at my other video. The general solution is c e to the at minus b over a. If you have a linear constant coefficient differential equation. Therefore, the solution for v is equal to c e to the negative 8t minus 2. And keep in mind that this is b and this is a. That's how I end up with 2. From here, we know that v is equal to y to the negative fourth. So we can say y to the negative fourth is equal to c e to the negative 8t minus 2. And we can solve for y and get the implicit solution by raising everything to the negative 1/4 power. So y is going to be equal to c e to the negative 8t minus 2, all to the negative 1/4 power. And this will be your implicit solution for y.